This is chapter 5, section 5, and it's equilibrium in 3 dimensions for a rigid body. Okay, so first steps, we need to identify the forces. And one force is given in this one with 2 direction with the door plane, and this forces is 800 Newton. Sorry, I forgot to write it. 800 Newton. So we need to find the force in Cartesian notation form. And for the unknown, we have 3 bearings and they all have a different orientation. So those 3 bearings together stop the moment, but not each bearing independently. Okay, so each bearings only exerts 2 forces. The bearing A, so we can see that the translation is on Y. So the 2 forces are on X, AX, and on Z, AZ. Okay. On Y, the translation is free. So the 2 forces that prevent the 2 other translation are on X and Z. B, the translation that is free is on X, like this. So we have a B Y and a B Z. Okay. And at the point C, the translation that is free is BZ. So we have a C X and a C Y. That's our 6 unknown, and we have 6 equations of equilibrium, so we don't want more. Okay, first steps, let's find F as a vector. Cartesian notation form. Okay, so F, so you see this one is in this plane, and this door is in a plane like this. Okay, so for Fx, it will be equal to cosine 60 degrees up. Now we are on the F prime there. This is, you cannot see. And what can you use? Yellow? At the F prime, the yellow one. Okay. So cosine 60, and for x, so this one is cosine 30 degrees time F. For Fy, so Fy there. So Fy there. Cosine 60 again to go to F prime, and after that the opposite, so sine 30 degrees time F. And for Z, Fz, it's equal to minus because it's down, so it's this one, and at the opposite side, at this one, so it's sine 60 degrees time F. Okay, and remember that F is equal to 800 Newton. Okay, so I will replace by 800 everywhere. So F as a vector, it's equal to cosine 60 degrees cosine 30 degrees times 800 on I hat plus cosine 60 degrees sine 30 degrees times 800 on J hat, and minus sine 60 degrees times 800 on K hat. Okay, let's solve for that with the calculator. I want to keep out those numbers. So cosine 60 cosine 30 times 800. So that's 346 on I hat cosine 60 sine 30 times 800, 200. So plus 200 on J hat, and sine 60 times 800. So minus 693 K hat, and it's Newton. So we did the first step. We found the force F at this point O. Let me square that. Now, to solve for our equation, we will use our table with the point, the vector position, the force, and the moment. All those unknown are 2 unknown, 2, 2, and 2. And at F, our force F has 3 components. When we want to multiply this by the moment, it will make something long. So let's use the point O there as our 0. Okay, let's call this one O, and that's where our graphs are written. Where I do my table. There. Let's do my table there. Okay, so we have I don't want to squeeze too much. Point. R O to the point, force, and moment. Shoop. Yeah, I know. That will be challenging. I never have enough space, either on a whiteboard, on a regular whiteboard, or on my tablet. So point O, at the point O, R O O is equal to 0. The force F is equal to this crazy force there, and the moment it's equal to 0 because we multiply by 0. Okay, point A, R O A, it's equal to from O to A, it's equal to minus 2 J at, and the force is equal to AX I at plus AZ K at. And now the moment, so J cross I minus, so plus 2 AX on K, and J cross K, it's plus I, so minus 2 AZ on I at. Okay, that's where we all do mistake, including me, because we need to think about J cross I, that is K, J cross K, that is I, and we think about AX. Now AX is on K, AZ is on I. Everything is screwed, so that's make easy to do mistakes. So take your time for those cross products. Okay, let's do at the point B. P, so B we need ROB from O to B. It's minus 1 I at. Be careful that X is plus in these directions, Y is plus in these directions, and K in these directions. You need to include the minus, otherwise it's false. It's like your bearing is on the side. Okay, the force, so it's By on J at plus Bz on K at. The moment, so R cross force, I cross J plus K, but there's a minus, so minus By on K at, and I cross K, it's minus, plus, so plus Bz on J at, yes, on J at. And the last point, C, okay, it would be something like this. Boop, 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 boop. Yeah, it's better when it's with a ruler, but that's fine. Okay, point C, so ROC, it's equal to OC, so from O to C, so minus 1.75 on I at, this one, and plus 2 on K at. CX I at plus CY J at. You don't see it, but I do see it. There. Moment. Okay, let's write for this one. So I need to do minus 1.75 I at plus 2 K at cross product CX I at plus CY J at. Okay, so Let's look first at this one. So minus 1.75 I at times Cx I at 0 minus 1.75 I at plus this one J at, it will be K, so it will be minus 1.75 Cy on K at for this one plus this one. And now let's do this one. So 2K at K plus I, it's minus, so minus 2 Cx on J at. So that's an x. And K cross J, what did I say? K cross I is plus, sorry, it's plus. K cross J is minus, so minus 2 Cy on I at. Take your time. 3D problems are a nightmare to solve for students and for me. Just because it's so long. It's not hard, it's so long, and there's so many ways to do mistake all the time. So, okay, so now I will write my sum of the forces on x is equal to 0. And I tell you right away, there's 6 equations and they are all dependent to each other. Not independent, but I mean, they all include more than one unknown. So we need to take our time. Okay, let's do sum of force on x. So in F, we have this one, don't forget this one on I at, and this one on I at. So that's my sum of the forces on x. So it gives us AX plus CX. It's minus 346. It's equal to 0. So AX plus CX, it's equal to, oh, not minus, plus, equal to minus 346. Equation number 1. Sum of the forces on Y is equal to 0. Let's do arrange. So Y, we have the minus 200 there, the BY, and the CY. So it's BY plus CY plus 200, it's equal to 0. So BY plus CY, it's equal to minus 200. Okay, so that was the FY. Let's do K. Oops, should be here. So, sorry, I forget to write. Sometimes I have some French words. Sum of the forces on Z is equal to 0. So on Z, we have this one with a minus in front. We have AZ and we have BZ. So we have AZ plus BZ minus 693, it's equal to 0. So AZ plus BZ, it's equal to 693. That was Z. Okay, so 1, 2, 3 equations. Now we need the equation of moment. So sum of the moment about O but on X, it's equal to 0. Blue one. On X, we have this one and this one. Yay. So we have minus 2 AZ minus 2 CY, it's equal to 0. And that's it. So we can just write that AZ plus CY, it's equal to 0 if we divided everything by minus 2. That would be easier. So that's the moment on X. Sum of the moment about the point O but on Y. So on Y we have BZ and CX. So it means that BZ plus 2CX is equal to 0. That's my moment about Y. And sum of the moment about the point O on Z is equal to 0. Right, right? So K, K, and K. So that gives us 2AX minus BY minus 1.75 CY is equal to 0. And let's square all those equations. Okay, we have these equations, 6 unknown. We need a matrix to solve for that. So let me make it a little bit smaller. So we can write all our equations. Too small, otherwise you cannot see. That's my crazy matrix. Time -1 time the matrix with everything I know. Okay, so let's write in this order. So AX, CX, BY. Oh, I need more space. Sorry. Let's make it a little bit smaller. I really need more space. And you know what I will use the ruler to have something nice. So 1, 2, 3, 4, 5, 6, and something in the other direction. So we will be able to see correctly the matrix. 1, 2, 3, 4, 5, 6, and the 1 with the equal to the right. Okay, let's clean out a bit this. Okay, so I will put everything that is in front of the AX, CX, BY, CY, AZ, and BZ, and there is everything. And I will inverse this matrix and I will multiply by this one. So AX, so this first equation, AX is when 1, AX 1, CX1, everything else is 0, and minus 346. 0, 0, 1, 1, 0, 0, and minus 200. This one, 0, 0, 0, 0, 1, 1, and 693. Here I will zoom. Okay, now the equation of moment. For the equation of moment. So we have 0 AX, 0 CY, 0 BY, 1 CY, 1 AZ, 0 equals 0. We have 0 AX, 0 CX, 0 BY. Oh no, we have 1 CX, sorry. Oh no, we have 2 CX. 2 CX. Oh, 0, 0, 1 is equal to 0 for this one. And here we have 2 AX, minus 1 BY, and minus 1.75 CY, and everything else is 0, 0, 0. So now you need to take your calculator and create your big matrix. Okay, so matrix, edit your matrix number 6. So I already have one. That is very close. So 0, 0, 0, 1. You really hope you didn't make any mistakes. That's so crazy. I crossed my finger. And 1, 2. Okay, and after that you write in the matrix 6 by 1 your vertical matrix there. So minus 346, minus 200, 693. You call your matrix. So probably the matrix 5, matrix E. So matrix E minus 1 times F. Cross my finger. And we find, okay, so we find AX, it's equal to minus 401.5 Newton. Cx, it's equal to, so it's in the same order than here, 55.5 Newton. By, it's equal to 604 Newton. Cy, it's equal to minus 804 Newton. And AZ is equal to 804 Newton. And BZ, it's equal to minus 111 Newton. That is close to the book, except some sign, but I don't know. Okay, that will be fine. And when I have matrix with 6 by 6, I prefer to use Excel if I have Excel available on my computer. I made a little video to explain how to do a system of matrix in Excel. So here we go. So what we have there, that the reaction in each bearing. So we have the bearing A, we have the pipe, bearing B, and bearing C in this direction. And so we found the force. So now AX, we have a AX that is equal to 401. We have a AZ is equal to 55.5. We have BY that is equal to 604. No, sorry, I read 6. 804. BZ 111. Cx 55.5 and Cy minus 804, and of course the force F that we have since the beginning. Here we go. So that's what we get. I wish you I don't know, great evening, great morning, great day, great weekend. But that's your last video for the chapter 5. Bye bye.